I want to talk a bit about this change of sign, and this is to do with finding the critical points. Why do we do it? Why do we find when is the bottom of the fraction equal to 0? What's the point? Here's the thing. Functions will only change sign. It's only possible to go from positive to negative at x-intercepts. Right? You can't go from positive to negative without passing through 0. So the x-intercepts, if you like, the zeros. The other time it could change sign is discontinuities. For example, let's have a look at our hyperbola over there, y equals 1 on x. It changed from positive to negative. It didn't actually pass through 0, that one, because of the asymptote. So they're the two key things, finding asymptotes, finding x-intercepts. They will give you the critical points of your solution. So you get something like this, x minus 1 squared, x plus 3, this now shouldn't be an issue because we know the key points are going to be the solutions to this equation. I can draw a picture. I've got 1 and negative 3. Now if I was to draw this graph, we know we've got a double root at 1, we've got a single root at 3. It would end up doing something like that. How high up it goes, I don't really care because I'm only interested about when is it positive, when is it negative. So what is this question now asking? When is this graph below the x-axis? Well, there's the two critical points. They're both included because it's an equal to sign as well. But I'm only below for that bit there. So the solution to this one would be x is less than or equal to negative 3. But another possibility is x equals 1, and you'd be surprised how often that single point is forgotten because we think, oh, inequality, we must have an arrow going somewhere. Well, no, you don't have to. This single point satisfies the equation. That's okay. But this is one where you check your regions. You don't automatically assume I'm either in between or on the outside, because you can see that's not the case with this one. It's just on the left-hand side of those points. So you really need to check all three sections if you're doing it that way. Let's have a look at the pronumeral and the denominator then. This gives us another way of solving this question. So here's way number 3. What I could do is move everything to the left-hand side and make it an algebraic fraction, and I end up with this. And we said, okay, it can only change sign two possible ways. If it was equal to 0, or if I had an asymptote, if it was undefined. Critical points. The zeros, well, that's the top of the fraction. If a fraction equals 0, it must be the top of the fraction equals 0. So I solve the top of the fraction, I get minus 13 on 5. The discontinuities, the asymptotes, well, that's the bottom of the fraction. Bottom of the fraction equals 0 at negative 3. I get those two critical points. Plot it on the number line, test my regions, and I come up with the solution. So it is similar to the first one. It's probably a bit more work, but it is another way of doing it. Bring everything to one side, make it one fraction, and look at the top of the fraction equals 0, bottom of the fraction equals 0. That gives you your boundaries for your equation. 5b we'll add to our exercises.